Namaskar, welcome to Sai Economics Point. In today's lecture, we will discuss linear programming problem using BigM method. Okay, suppose the objective function is minimize c equal to 3x1 plus 2.5x2 and subject to 2x1 plus 4x2 greater than equal to 40, and second constant is 5x1 plus 2x2 greater than equal to 50, and x1 and x2 is greater than equal to 0, which is your non-negative constant. Okay, so for solution, okay, we have to write the standard form of the LPP first. Okay, so for standardization, we have to check the constants. Okay, see, all the two constants in the minimization problem are greater than equal to 4. Okay, so to make this inequality into equality, we need to subtract the surplus variable. Okay, and add the artificial variable. Okay, so the first constants, okay, become by subtracting the surplus variable and by adding the artificial variable, the first extended constants becomes your 2x1 plus 4x2 minus s1 plus a1 equal to 40. So by subtracting the surplus variable and adding the artificial variable, this inequality now becomes equal. Okay, now similarly in the second constants becomes, say, 5x1 plus 2x2 minus s2 plus a2 equal to 50. Okay, so now we will see the standardization form of the objective function. Okay, and the objective function, this becomes c equal to 3x1 plus 2.5x2 plus 0s1 plus 0s2 plus m a1 plus m a2. Okay, see, m here represents a number higher than any finite number, so it is called Bm. Okay, and one thing you have to keep in mind that for minimization we assign the objective function of a coefficient of a, okay, m in positive. Okay, that is for artificial variable, right? So now if we form these equations into a matrix format, then this will become uh, 2 4 minus 1 0 1 0. Okay, see here 2 means the coefficient of x1. Okay, 4, this is the coefficient of x2, minus 1 coefficient of s1, 0 represents s1 is absent here. Okay, so as a1 is present here, okay, that is 1, and a2 is not there, so take 0 for that. Similarly, okay, here the coefficient of x1 is 5, the coefficient of x2 is 2, and here s1 is not there, so 0, take 0. So s2, for s2 take minus 1, and a2 1, and a1 is not there, so take 0, and multiplied by x1 x2 s1 s2 a1 a2, and this equal to 40 and 50. Okay, so from the above information, now we will formulate initial basic feasible solution table. Okay, here cb represents coefficient of a basic variable, and in the basic variable column we will take the artificial variable. Okay, a1 and a2. Okay, and the coefficient of a1 and a2 is m. Okay, so here we will take m. Okay, now we will put the values of x1 and x2. Okay, from the given matrix format. Okay, so we will write here 2 4 minus 1 0 1 0. Okay, and in constant or solution column we will write 40. Okay, Then next, here we'll write 5, 2, 0, minus 1, 0, 1, and here we'll write 50. Okay, and next, here this is your B is a row. Okay, so B is a represents coefficient of a objective function. Okay, the coefficient of objective function is here 3, 2.5. Okay, and 0 and 0. So we'll put here. Okay, 3, 2.5, 0, and 0, and a1. The coefficient of y1 is m, coefficient of m2, this is 0, again m. Okay, next we'll calculate the values of zj. Okay, and zj, as you know, zj equal to summation of cb into aij. That means summation of a product of a coefficient of a current basic variable and respective coefficient in that row. Okay, so let us calculate the values of z1, z2, and so on. Okay, so here see z1 equal to m into 2 plus m into 5. Okay, so this will become your 7m. Okay, z2 equal to m into 4 plus m into 2. So this equal to your 6m. Okay, and z3 equal to m into minus 1 plus m into 0. Okay, so this equal to your minus m. Okay, the next m into 0 plus m into minus 1. So this again becomes your minus m. Okay, now z5 equal to m into 1 plus m into 0. So this equal to your m. Okay, the next z6 equal to see m into m into 0 plus m into 1. Okay, so this equal to m. So this is how we can calculate the values of z, right? Next, we'll calculate the values of z. Okay, delta z, which is the net evaluation row, or you can say it is the indicator row. Okay, so here we'll calculate by applying the formula bj minus zj. Okay, so here it will become 3 minus 7m. So right here 3 minus 7m, and here it will become 2.5 minus 6m. Okay, and here it will become 0 minus m, it will become m. Here again 0 minus m, again this becomes plus m, right? Now we have to check which one is the largest negative magnitude in order to find out the key column. Okay, so out of this, which one is the largest negative magnitude? Okay, so this one. Okay, so see, this is your this value is your largest negative magnitude. Okay, which decides your key column, or this is your pivot column. Okay, now after getting the key column, okay, we have to find out the ratio, displacement ratio. And how can we find out? This is displacement ratio equal to, okay, constant column divided by pivot column. Okay, so this equal to, so here 40 by 2, for 40 by pivot column. Okay, 40 by 2, so this equal to your 20. Next 50 by your pivot column value is here 5, so 50 by 5, 50 by 5 equal to 10. Okay, now we have to find out, okay, the pivot row. How can you find out that? The pivot row, okay, so here the smallest positive number decides the pivot row. So here the smallest positive number is 10. So this decides your pivot or the key row. So this is your key row, and this is your key column. Okay, so this is your pivot column. Okay, and this value, sorry, this row is your pivot row. Okay, now the intersection of a pivot row and pivot column, okay, is your 5. This is 5. Okay, so this becomes your key element. This becomes your key element. Okay, so after getting the key column, the next task is we have to find out, okay, which one is existing variable and which one is a entering variable. Okay, see, the key column decides the entering variable. That means it is your entering variable. Okay, and the pivot row, okay, the pivot row or the key row decides the existing variable. So this is the existing. A2 is the existing or outgoing variable, and x1 is the entering variable. So while formulating the second BFS, x2 comes here and a2 will be out. Okay, now we'll formulate BFS 2. Okay, so here we'll write the basic variable. Okay, so as you know from the initial IBFS, okay, A2, this is the outgoing variable, and x1 is the incoming variable, and A1 will exist here. Okay, so here we'll write A1, and here x1 enters, and the coefficient of A1 is m, and the coefficient of x1 is 3 here. Okay, and now we'll write the values of R3 and R4. Okay, so before that, as you know, this column will remain constant, so we'll write the values of Bj. X1 is 3, and x2 value is 2.5, and s1 it is 0, and s2 it is 0, and for a1 it is m, for a2 it is m. Okay, now we will calculate the values of r3 and r4. Okay, as we know, the formulation of second BFS is to make the key element 1 and all other elements in the pivot column 0. Okay, so how to calculate it? Just check it. So the new value, that is R4, equal to, okay, R2 into 1 by 5. Okay, see, if we multiply, okay, 5 into 1 by 5, that is, if you multiply 1 by 5 with the key column, then this will become 1. Okay, so to calculate the new values, we have to apply this formula. So the new value equal to 2 value, that means the old value multiplied by 1 by 5. Okay, so this is your formula is old value multiplied by, this is multiplied by 1 by 5. So the new value equal to old value multiplied by 1 by 5. Okay, now let's calculate the values of the new values, that is the values of row 4, new value. Okay, so how can we calculate this? Say 5 into 1 by 5. Okay, this becomes your 1, so right here 1. Okay, then the next is, say 2 into 1 by 5, so this becomes your 2 by 5. So this becomes your 2 by 5. Okay, then next is, say next is 0 into 1 by 5, so this becomes your 0 here. Okay, and the next is, say minus 1 into 1 by 5, so this becomes your minus 1 by 5. Okay, then the next one is 0 into 1 by 5. Okay, so this becomes your 0. Then the next one is next one is, say 1 into 1 by 5, so this becomes your 1 by 5 here. Okay, then the next one is, say next one is 50 into 1 by 50 into 1 by 5. Okay, so this becomes your 50 into 1 by 5 equal to here 10. So this becomes here 10. Okay, so now next we'll calculate the values of row 3. Okay, so we'll calculate the values of row 3. So here the new value equal to, the formula is old value minus 2 times revised, 2 times revised pivot row value. Okay, so the new value equal to old value minus 2 times revised pivot row. This is the revised pivot row value. So with the help of this new value, that is the revised pivot row value, we can calculate the row 3 value. Okay, so just apply the formula and calculate the values of row 3. Okay, so see the new values are 1 2 by 2 by 5 0 minus 1 by 5. Okay, 0 1 by 5 and 10 is here. Okay, so we have to calculate row 3. So to calculate the values of row 3, the formula is r1 minus 2 multiplied by r4, that means old value, minus 2 times revised pivot row value. Okay, so let's calculate it. So this equal to old value, that means R1. The values of R1 see here 2. So 2 minus 2 into R4. This is okay, 2 into 1. Okay, so this equal to 2 minus 2 equal to 0. Okay, then the next is see row 1 minus 2 into row 4. So row 1 value is 4. See, this is 4. 4 minus 2 into 2 into 2 by 5. Okay, so the revised pivot row value is 2 by 5. So 2 into 2 times revised pivot row value. So this equal to your 16 by 5. Okay, then the next one is minus 1. See, minus 1. Okay, minus 1 minus 2 into 0. 2 into 0. So this equal to your minus 1. Then the next one is here, see, 0. Okay, 0 minus, okay, 0 minus 2 times multiplied by minus 1 by 5. Okay, so 0 minus 2 into minus 1 by 5, this equal to your 2 by 5. Okay, then the next one is 1 minus, okay, 2 into 0. Okay, 1 minus 2 into 0. So this becomes your 1 minus 2 into 0. This equal to your 1. Then the next one is 0 minus 2 into 1 by 5. So 0 minus 2 into 1 by 5 equal to minus 2 by 5. Then the next one is 40. Okay, 40 minus 2 into 2 into 10. Okay, sorry, 2 into 10. So this becomes your 40 minus 2 into 10. So this equal to 20. So now the values of row 3 equal to 0, 16 by 5 minus 1. Okay, minus 1, 2 by 5, 1 minus 2 by 5 and 20. So just put the values in the backface 2 here. Okay, so this equal to your 0, 16 by 5 minus 1, 2 by 5, here 1, okay, 1, then minus 2 by 5 and here it is 20. Okay, now we have to find out the values of zj. Okay, so now let's find out the values of zj. So zj equal to, here z1 equal to m into 0 plus 3 into 1. Okay, so this equal to your 3. Okay, and z2 equal to m into 16 by 5 plus, okay, 3 into 2 by 5. So this is your 16m, okay, plus 6 by 5. Okay, and here m into minus 1 plus 3 into 0. Okay, so this equal to your minus m. Okay, and z4 equal to m into 2 by 5 plus 3 into minus 1 by 5. So this equal to your 2m minus 3 by 5. Okay, and z5 equal to m into 1 plus 3 into 0. This equal to your m. And z6 equal to m into minus 2 by 5 plus 3 into 1 by 5. So this equal to your 3 minus 2m, okay, by 5. Okay, now we'll calculate the values of indicator row. Okay, so the formula is bj minus zj. So this is 3 minus 3 equal to 0, and 2.5 minus 16m plus 6 by 5. So after simplification, here we'll get 18.5 minus 16m by 5, and here 0 minus minus m equal to plus m, and this equal to 0 minus 2m minus 3 by 5. After simplification, we will get the value here 3 minus 2m by 5. Okay, here m minus m equal to 0. Here m minus 3 minus 2m by 5. This becomes here, after simplification, 3m minus 3 by 5. Clear? So this is how we will calculate the values of a indicator row. Okay, and this is your calculation of a z value for second bfs. Okay, now we have to check for the optimality test. Okay, so this represents, this values represents there is a suboptimality, so we need improvement. Okay, so next to decide the key column, we have to find the largest negative magnitude. Okay, see, this one is the largest negative magnitude because here this is minus 2m, here this is minus 16m. So this one is your, and the largest negative magnitude here besides the pivot column, or this is the key column. Okay, so this becomes your key column, this is your key column. Okay, now we have to find out, okay, the ratio, displacement ratio. So the formula is b by pivot column, that is 20 by 16 by 5. Okay, so this becomes your 25 by 4. Okay, the next is 10 by 2 by 5. So this becomes your 25. So this is 25 by 4 and this is 25. So this one is the smallest positive number. So this one is the smallest positive number, and this decides your key row. This is your key row. So this is your key row. This is your key row. Okay, and this one, the intersection of a pivot row and pivot column, this decides your key element. This is your key element. Okay, and as you know, the pivot column or the key column decides, this one is your entering variable in the next VFS. Okay, and pivot row, this one, okay, this one is your existing or outgoing variable in the formulation of a next bfs. Okay, and the objective of a formulation of a third bfs is to make this element 1 and all other elements in the pivot column 0. So we have to make this one 1 and make this one 0. Okay, so let's formulate bfs 3. Okay, as you know, in second BFS, okay, say a1 will the outgoing variable and x2 will the entering variable. Okay, so say, so here x2 enters and a2 outs. Okay, and x1 is already exist. Okay, and the values of x2 is here 2.5. Okay, and the values of x1, that is coefficient of x1 is 3 here. Okay, and now the b is this represents the coefficient of the objective function, and this will remain same. Okay, now we'll calculate, okay, the new values, that is values of r5 and values of r6. Okay, for r5, for r5 this element should be 1 because this is the key element and we have to convert this into 1. Okay, so what is the formula? So this is the formula to find out the new value or the find out the values of row 5. So this is the old value multiplied by 5 by 16. Okay, because here there is 16 by 5. If we multiply 5 by 16, okay, then we will get 1. And we have to multiply this 5 by 16 to each and every element of this row 3. Okay, then we'll get the new values for R5, right? So the new value here, R5, this equal to say 0 into 5 by 16. Okay, that is R3 into 5 by 16. So 0 into 5 by 16, this becomes 0. Okay, so here 16 by 5 into 5 by 16, this will become 1. Okay, because our objective is to make the key element into 1. So this will become 1. Here minus 1 into 5 by 16, this will become minus 5 by 16. Here 2 by 5 into 5 by 16. Okay, 2 by 5 into 5 by 16, this will become your 1 by 8. Okay, and here 1 into 5 by 16, this will become 5 by 16. Okay, minus 2 by 5, okay, into 5 by 16, this will become minus 1 by 8. Okay, and 20 into 5 by 16. Okay, so this will become your 6.25 or 25 by 4. Okay, next, we will calculate the values of R6. Okay, and our objective is to make this element 0. Okay, so for that, the formula is old value minus 2.5 times revised pivot row value. That is R4 minus 2 by 5 R5. Okay, now we'll calculate the values of row 6. Okay, so the formula is row old value minus 2.5 times revised pivot row value. Okay, so here this becomes your old value is 1. Okay, so 1 minus, okay, 2.5 times of 0. So this will become your 1. Okay, the next one is, okay, old value is 2 by 5. 2 by 5 minus 2 by 5 times of revised pivot row, that is 2 by 5 into 1. So this will become your 0. Okay, then next is old value 0 minus 2 by 5 times of a revised pivot row. Okay, so this is your 1 by 8. Okay, then the next is, okay, minus 1 by 5, that is old value minus 2 by 5 times of a revised pivot row, that is minus 1 by 5 minus 2 by 5 multiplied by 1 by 8. So this becomes your minus 1 by 4 after simplification. The next is old value, okay, old value, that is 0 minus 2 by 5 times of 5 by 16. So this becomes your minus 1 by 8. The next is old value, that is 1 by 5 minus 2 by 5 times of minus 1 by 8. So this is your 1 by 4 after simplification. The next is old value, that is 10 minus 2 by 5 times of 16.25. Okay, so this is your 15 by 2. Okay, so this is your new values for row 6. Okay, then next we will calculate the values of zj. Okay, so here z1 equal to 2.5 into 0 plus 3 into 1. So this equal to your 3. The next 2.5 into 1 plus 3 into 0. Okay, so this equal to your 2.5, right? The next is z3 equal to 2.5 into minus 5 by 16 plus 3 into 1 by 8. Okay, so by simplification we will get the value here minus 0.406. Okay, then the next z 4 equal to 2.5 into 1 by 8 plus 3 into minus 1 by 4. So this becomes your minus 0.437. 437. Okay, here z5 equal to 2.5 into 5 by 16 plus 3 into minus 1 by 8. So this becomes your 0.406. Then z6 equal to your 2.5 into minus 1 by 8 plus 3 into 1 by 4. This equal to your 0.437. Now, after getting the value of zj, now calculate the value of a indicator row. So, this is the formula is vj minus zj. So, 3 minus 3 is 0. 2.5 minus 2.5 will get 0. 0 minus 0.406, this becomes positive 0.406. Next 0 minus 0.437, 0.437. Here m minus 0.406, m minus 0.437. Okay, so now check for the optimality test. The indicator row shows that nothing is negative. Okay, so optimal solution is possible here. Okay, and the values here, okay, the values in the constant column and solution column is the optimum values. Okay, so this is your optimum values. So x1 the solution value is 7.5 and x2 the solution value is 6.2. Okay, so x1 optimum equal to 7.5, x2 optimum equal to 6.25. Now the optimum value, that is c, minimization of c, this equal to 3 into 5, 3x1 plus 2.5x2, 2.5 into 6.25 equal to 38.125. So this is the optimum value through Big M method. Okay, uh, I hope this video is very helpful. If so, please like, comment and share. Okay, thank you. Have a nice day.